All right, hello people watching the video. We are on the chapter review, or the yellow sheet that we're filling in. We've got standard deviation to do, and then we're going to talk through some of the review problems, and I'm going to give them time to work. So we had two methods for standard deviation, just like we did for mean, and critical value confidence interval. The things that we need for standard deviation. I need some formulas, so you guys got to help me out here. We need to know, let's start with this guy. And this guy. Those are the symbols that we use for standard deviation. Which one is the claim?
Top.
The top one. Sigma is the claim one. The other one has to do with our sample. Okay? Sometimes they will give you X bar, which is the average. Okay? I think I did that to you on the quiz the other day. But you do not actually use X bar in anything when you're calculating standard deviation. So you can put that down. They might give it to you, but we don't need it. Okay? What else do we need? I'm trying to think. I don't know. N, maybe? N is the number in the sample. Okay. And then, yeah, maybe. I'm trying to think of what our formula is even. Does somebody have that? God bless you, Sarah. God bless you, Sarah. I want to look at yours.
She sneezed.
Equations. Yeah, here we go. Yeah, so that's all we need for our stuff. Formulas for critical value method. The symbol that we use, like instead of Z or T, like we did up here, like it was called Z, or it was called T, or it was called Z up here for your proportions, okay? This one is called chi-squared. Now, don't get confused. You don't actually have to square anything. It's just what it's called, all right? And it is n minus 1 times s squared over sigma squared. That's how you calculate him. That is the formula that you use. And that is all. Again, you don't have to square anything like additional in the formula besides the s and the sigma, okay? That's how you do that, okay?
Oh, wait. You're moving faster than my little brain to keep up.
Okay. I'm going to go ahead and write down confidence interval method because up here, in proportion and in mean, you found an error. Are you listening?
Mm-hmm.
For proportion and mean, you found an error and you added and subtracted it. You do not do that for confidence interval for standard deviation. He has two individual formulas, and they are this. S squared over chi squared, right? Write these down, Emma Carr. Emma.
Yeah.
Okay. I'm not going to let you photocopy anybody, so you need to write your own down. Get to writing. There is the confidence interval for standard deviation, okay? It's not an error that you add and subtract every time. Okay, notice that the right one goes on the left side and the left one goes on the right side because like we flip-flop them, otherwise we would end up with like a bigger number on the left and stuff like that, okay? Like that's it for, I feel like those boxes are kind of empty. I don't know. Okay. All right, let's go to the scenario. Can I scoot over? Are we doing okay? All right, standard deviation for heights of 53 freshmen. What's that? N is 53. Okay. Was 4.2. What is 4.2? S, the standard deviation for our value, okay? Test the claim that the standard deviation is greater than 4. So we want to know sigma is going to be 4, but for our hypotheses, we want to know greater than 4. Okay, so what's the null going to be?
Sigma is equal to?
Equal to 4, and sigma is greater than 4.2. Okay, the top one's always equal. Which one is the claim?
The bottom.
Claim goes with the bottom. Okay, now 4.2, oh, sorry, yes, I just looked at that as well. Yep, just 4. You're right. Okay, that's my claim. All right, equal to, greater than, there we go. Okay, our fish value is 0.05 or 5%. Got it? Good? Okay, let's do I'm going to do my calculation for this chi-squared thing right here. And let's figure out what our test value is. So chi-squared is n minus 1. So 53 minus 1, if you want to just write down 52 to save space, that's fine. Times 4.2 squared over sigma squared, which is 4 squared. Okay? And there is that. Somebody calculate that for me, would ya? This guy, 4.2 is squared, and so is the 4 squared.
57.33.
Our chi-squared value is 57.33. Okay? All right, now, what we're testing for our hypotheses is we want to know if 4.2, which is our number, if that's equal to 4, if that's greater than 4. I get 4.2 is greater than 4, but is it big enough to say that everybody's sample would be bigger than 4, right? Like, is 4.2 far enough away to say that that would be true, right? That's what we're really looking at, okay? So 57.3, that is our test value, okay? Let's do our bell curve here, and let's see what we get. Do we gonna do left-tailed, right-tailed, two-tailed? What do you got?
Right tail.
Right-tailed, because greater than. So I'm just gonna shade that one. What percent goes in there?
5.
5%, right? The whole percentage goes in there. We don't have to split it. Then we have an imaginary 5%, which means we're looking at 90% in the middle. So our numbers that we get here and here are based on 90% and how many degrees of freedom?
3.
52. We don't have a
Oh,
52 on the
agreed.
chart.
50.
So
Hello.
50.
So we're looking at 50, okay? You always like assume less accuracy than what you can, right? We can't assume to be more accurate. So we're going to use 50 instead of 60, right? And at 90%, you have two numbers, okay? You're on a chi-squared chart. Yes, I'm ready. What do you got?
37.689.
689.
63.167.
Perfect. Okay.
7.
Did somebody verify that and make sure
Yeah,
that's
he's
true?
right.
Yes, okay. Perfect. Great. Now all we have to compare is our test value. The
Ours lives
test
in the
value that
middle.
we got was 57.33. And he lives, I don't know, like a little bit to the right, right? A little bit to the right of that middle point. But which one are we going to circle out of these two?
The top one.
The top one. That means he's equal to. He is not greater than. He is greater than. 4.2 is greater than, but not significantly greater than, right? So, fail to reject.
H not claim false.
Fail to reject. H not. And the claim is false. That means it would not be greater than 4 for every sample that would ever exist. For our sample it is, but it would not be for every sample. Got it? Okay, same conclusions, but using this confidence interval method, okay? So sigma lives in between these two numbers, all right? And we've got the square root of n minus 1, which is 53 minus 1. And we've got s squared, which is 4.2 squared. And then on the bottom, okay, so it's similar to this formula right here, except we're taking the square root and we use the chi-squared right value, okay? Chi-squared right is the number that we got from this chart, right? 63.167. Okay, the other one is the same formula, so if you type it in once, you can just swap that number out. 4.2 squared. Wouldn't be a bad idea to practice typing this in just to make sure that you can do it right. Okay, and this is your chi-squared left number.
Ready?
Yep.
The right side, so the left side.
So the left side, okay.
3.81.
3.81.
I got 3.85.
And then 4.93.
4.93. Okay, somebody else check it. A third person.
3.81.
You got 3.81?
You do 4.2 on the top.
And then
Did you do 53 minus 1 or 50?
I know what it is.
So 4.
You used 50? Did you use 50?
No, I put 53.1 instead of.
Oh,
53
gotcha.
minus
Okay. All right, so those are our two numbers. Now what do we do with this?
4.2 lives in between it, so we get the same.
4.2. No. We're not looking at 4.2 though.
We're looking at 4.
We're looking at 4. Does 4 live in there?
Yes.
Yes. So that means we circle it, right? Like we did the same thing. We circle this, cross this off, which is the same result that we had up here. It should be. They should be the same result. Always. And no matter what method you use, it should be the same result. Okay? Got it?
Got it.
Perfect. Okay, questions about that? I'll leave that up there for a second. Sorry, I have this in the way and I should get rid of it. There we go. Okay, good?
Yes.
Okay, let's go down to the chapter review. The first couple questions, they're like, what is it even asking? Okay, using the method of this chapter, we have 3 different charts. 3 charts that we are using, okay? The charts are the Z chart. The other one is the t-chart.
And chi-squared.
And the other one is the chi-squared chart. Okay? Do you know which one is which?
Yes.
If you don't, you better catch up. The z-chart, you only ever look at the bottom corner, right? For this chapter. Okay? Well, I guess that's not true. When you're doing the p-value method, you do look at the inside part. But the bottom corner is what you're looking for your critical value, okay? Z-chart, t-chart, chi-squared chart, okay? They say using the methods of this chapter, identify the distribution or the chart that you're going to be using if you have a mean, if you have a proportion, if you have a standard deviation.
Mean is Z.
Kind of.
Mean Z or T.
Mean is Z or T depending on the information that you're given, right? Okay? So mean, that's the one where you have to choose, okay? And it has to do with like the n greater than 30 type of thing, whatever, okay? Proportion is always going to be
Z.
Z. Standard deviation is always going to be
Chi-squared.
chi-squared. Does that make sense? That's what they're asking for on number 1. Which distribution or which chart do you use for that? Got it? Okay. Number 2, determine whether the given claim involves a hypothesis left-tailed, right-tailed, or two-tailed.
Two-tailed left, right.
Two-tailed. Okay. And this one will be, you said left?
Yes.
And this one will be right. Do you understand that?
Yep.
Okay. Now, each one of these will only ever be your H1, right? Because H naught is always equal to, correct?
Yes.
Equal to, and then either not equal to, less than, or greater than. Got it? And then that will tell you how many tails you have and which ones. Got it? Okay. Let's do this one. Number 3. In a Pew Research-centered poll of internet users of age 18 to 29. That information means nothing. I don't care that they're 18 to 29 years old. That means nothing. That's not even N. 53% said they use Instagram. Okay, they're giving me a percentage. And that is according to the sample.
P.
That is going to be
Hat.
P hat. Because that's based on my sample. So 0.53 is P hat. That's from the sample. We want to use a 0.05 significance level. That's my fish. To test the claim that, they always have those words, to test the claim that, look for those words. To test the claim that the majority, that tells me a number. P is equal to 0.5, but really, like when we put it under our hypothesis, that means greater than 0.5. So P equals 0.5 and P is greater than 0.5, right? Majority means more than half, okay? So which one is my claim for my hypotheses? The bottom one, right? Does this make sense? So majority, that actually is a number in there, all right? And then of internet users 18 to 29, there's that number again that I really don't care about. Use Instagram, okay? So majority use Instagram. Our number was 53%, which is a majority. But would that be true for if we would sample an entirely different group, right? Is 53% significantly higher than 50 that it would be true in all cases? Does that make sense? That's what we're trying to test, okay? So using a sample size of 532, that's a decent sized N, 532. Find the value of the test statistic. That's the test Z. And to do that, we do P hat minus P over the square root of PQ over N. That's what they're wanting you to find. Okay, I'm going to run out of room here. I'm going to go down here. P hat was 0.53 minus 0.5. But we're going to end up with a positive Z or a negative Z.
Positive.
Positive. 0.5 because we're above average, right? 53 is more than half or more than what the normal P is. 532. Okay? Find what that number is. I'm running out of room, so I'm going down. Sorry.
I got 1.38.
1.38. That sounds like it could possibly be right.
1.38.
Okay, cool. Z is 1.38. They want to use the p-value method. Okay, p-value means percentages, which means my chart is going to be 0%. Let me write it in a different color. 0% to 100%. Okay. All right, let's fill out stuff that we know about our charts.
It's one-tailed.
It's one-tailed and it's the
5%.
right one, right?
Oh,
Okay, one-tailed, the right one. We have an imaginary left one.
so 90.
My fish value is 5%, which means all 5% is going to go there and 5% here, which means 90% in the middle. Am I going too fast?
No.
Please stop me if I am. What?
No.
No? Okay, our 5% cutoff is here. Otherwise, this cutoff mark would be 95%. Okay, what's the next thing that I do?
Look up it on your chart.
Yeah, so 1.38, we're going to look up on our chart. This is not in the bottom corner. 1.38 goes on the side. Look that up.
0.9162.
0.9162.
0.9306.
Okay, 0.9306. This is called the p-value. So using the p-value method. Okay, so this is the test value. This is the test stat.
It's 0.9162.
It was?
You were right
Yeah.
the first time.
Oh.
0.9162. Okay, so our point or 1.38, we've converted it on the chart to 0.9162, which is 91.62%. And then all I do is look at where does it fall along this number line.
That's right.
It is to the left of 95. So it's still to the right side of the chart, but is it enough to say it's greater than 0.5?
No.
No, because it's not significantly greater than. So we're going to circle this one across this one off, right? I would really suggest you do that because then you can visually see, like, I crossed the claim off, right? Like, I know which one is true. So what should we do about the null and alternative hypothesis or null hypothesis? We should fail to reject. I'm just going to do FTR, H naught. Okay? What should we conclude about the original claim? Not a majority for Instagram. Okay? Or claim is false. So even though we had 53%, if I would sample another 500 people or another 1,000 people, it may not be a majority for them, right? 53% is not significantly high enough to say that that's a majority. Does that make sense? Okay, so that's what they're saying. Okay? Good? All right, we'll go through and we'll do the rest of these three and then I'll set you free on your own, okay? Number 4, true or false? In hypothesis testing, it is never valid to form a conclusion of supporting the null hypothesis.
False. Never say never.
Do we ever say that the null hypothesis is 100% true?
No.
We only fail to reject it. Do you remember why we do that?
Because it's not.
Because according to us and our sample right now, we're saying there's not enough information to say that this isn't true. But maybe another sample would say, nope, this is not true and this is true, right? But for right now, our data supports it and says, I'm going to fail to reject that it's not 0.5, right? So, true or false? In hypothesis testing, is never valid to form a conclusion supporting the null hypothesis.
False.
True. We never completely support the null hypothesis. We only fail to reject it based on our sample at that moment in time. We only say, I don't have enough information to say that that's not true. It might not be true, but I don't have enough information to say that it's not at this point. Okay? Does that make sense? That's kind of confusing. Number 5, conclusions, true or false? The conclusion of fail to reject has exactly the same meaning as accepting the null hypothesis. False, that's like what we just said. Okay? For our sample, I'm going to say only for our sample. Only for our sample it applies. Okay? But it might not apply to other samples. We might not get the same conclusion if we were given another sample. Okay? All right, last one, chi-square test. In a test of the claim where we have a standard deviation of 15 for the population of IQ scores, we find that the rightmost critical value is, I'm gonna draw a bell curve. The rightmost critical value is 40.646, and the leftmost critical value is the left critical value equal to negative 40.646.
No.
And when you're doing chi-squared, is that the way that operates?
No.
No, this number is going to be like 9 point something or, whatever, right? Chi-squared goes from 0 to an infinite number, right? It's not negative and positive like z-score. So no, not plus minus like z or t. Chi-squared has its own little set. That's why we don't use the error and we add and subtract the error. That's why we have to do a separate formula when we're doing the confidence interval method. Got it? Okay, good? Okay, you guys have proportion, mean, standard deviation. There are 2 of each kind. It would not be a bad idea to do some different methods. So like proportion, choose 2 of them. Maybe you want to do p-value here and you want to do critical value here. I don't care which one you use. You do whichever one you want, okay? I don't think we say, right? I don't think I say which one. So for mean and standard deviation, I would do a critical value and a confidence interval. Okay? Here I would do a critical value and a confidence interval. Okay? But for proportion, you only have 2 of them, so you pick 2 out of the 3, whichever ones you want. I would do some different methods just to test to see how you know. Okay, got it? You have 6 problems. Okay, do you know what you're doing?
Yes.
Practice this like it's a test, because if you can't do it now, you won't be able to do it on the test. Got it? Okay? All right, goodbye, people watching the video. Yeah. Yes, good.